Welcome. This video is based on the DC Theory Lab Annex-C.1. In part 3 of the lab, the student is asked to replicate Figure A and Figure B. Annex-C.1 is based on the construction of Figure B. There are 7 main steps to complete Table 7. These steps include setting voltage, identify resistors to be used, resistor measurements, install the jumpers, measure resistance, current, and voltage within the circuit. The first step is to set voltage. So to accurately set the voltage, we're going to use our multimeter here. We're going to have our multimeter in DC voltage. We're going to install our leads, one into the common. Our second lead will go into the voltage port. And the varying voltage power source we're going to use is the top right one up here, the positive voltage supply. So we're going to take our common lead, put it in the negative terminal, take our positive lead, put it in the positive terminal, and then we're going to turn on our supply. We're going to adjust that to 5 volts. And then just do final adjustments to get yourself right there to that 5 volts. Now that we have our voltage set to 5 volts, the next step is to identify the resistors to be used. Examining Figure B, we know that we need 9 resistors. If we look at this top row of white inputs, those are where our resistors are located. The resistors we need to complete our circuit are as follows. Resistor 1 needs to be 100 ohms, resistor 2 is 1000 ohms, resistor 3 is 2.2 kilo ohms, resistor 4 is 2.2 kilo ohms, resistor 5 is 3.3 kilo ohms, resistor 6 is 100 ohms, resistor 7 is 1000 ohms, resistor 8 is 3.3 kilo ohms, and resistor 9 is 4.7 kilo ohms. We're going to be using 9 of the first 10 resistors. So starting with the first resistor of 100 ohms, left to right, we have resistor 1, resistor 6, resistor 2, resistor 7, resistor 3, resistor 4, resistor 5, resistor 8, then we skip one and go to resistor 9. Now that we've identified our resistors and their locations on our electrical systems trainer, now we're going to verify the resistor measurements again using our multimeter. So using our multimeter to measure the resistance of each of these resistors, first we're going to change our meter to the resistor setting. When we're measuring resistance with our multimeter, we need to verify that the power is off. And now we can install our leads and start taking resistor measurements. We're going to take one lead, put it in our common port. We're going to take our second lead and put it in the resistor port. Now we're going to take the resistance of each of these values here. So we're going to start with R1, furthest to the left resistor. So very close to 100 ohms, we got 100.2 ohms. So we're going to identify that measurement and locate that into Table 7. We're just going to keep moving on down the line here.
Jumper 1. Installed from the positive side of the power source to the top side of R1. Jumper 2. Installed from the bottom side of R1 to the top side of R2. Jumper 3. Installed from the bottom side of R2 to the top side of R3. Jumper 4. Installed from the top side of R3 to the top side of R4. Jumper 5. Installed from the top side of R4 to the top side of R5. Jumper 6. Installed from the bottom side of R3 to the bottom side of R4. Jumper 7. Installed from the bottom side of R4 to the bottom side of R5. Jumper 8. Installed from the bottom side of R5 to the top side of R6. Jumper 9. Installed from the top side of R6 to the top side of R7. Jumper 10. Installed from the bottom side R6 to the bottom side of R7. Jumper 11. Installed from the bottom side of R7 to the top side of R9. Jumper 12. Installed from the bottom side of R9 to the top side of R8. Jumper 13. Installed from the bottom side of R8 to the negative voltage supply.
The fifth step of the lab is to measure resistance within the circuit. And this step is going to be broken up into 7 smaller steps. Those steps include 1, we're going to measure the total resistance. 2, we're going to measure the resistance of R1, R2. 3, we're going to measure the resistance of R3, R4, R5. Step 4, we will measure the resistance of R1, R2, R3, R4, R5. The fifth step will be measuring R6, R7. The sixth step will be measuring R8, R9. The final step will be measuring resistor 6, resistor 7, resistor 8, resistor 9. To find the total resistance of the circuit, we're going to remove jumper 1 and jumper 13 from our circuit and plug those into our multimeter. We have a reading of 9.91 kiloohms. Next, we're going to measure R1, R2. So we're going to go ahead and put jumper 13 back. Jumper 1 can stay in the meter here. And then we're going to take jumper 3 off of resistor 3. We got 1.116 kiloohms. Okay, now that we have the measurement for R1, R2, we're going to put those two leads back and remove the leads needed to measure R3, R4, R5. So J1, jumper 1 back to voltage source. J3, that'll go back to the top side of R3. Now we want to grab jumper 3 from the bottom side of R2. And jumper 8 from the top side of R6. 0.815 kiloohms. Next, we're going to put the leads back and put new leads on so that we can measure R1 through R5, get a total resistance between those 5 resistors. So we're going to put J3 back to the bottom of R2. And we're going to take jumper 1 back off the voltage source. The total resistance of R1, R2, R3, R4, R5, 1.931 kiloohms. The next resistance measurement that we're going to complete is R6, R7. We're going to go ahead and put jumper 1 back on the circuit. We're going to go ahead and take jumper 8 and install it back in the circuit. Jumper 8 will go to the top side of R6. Next, we're going to take jumper 8 off the bottom side of resistor 5. The next jumper we need is jumper 11 off the top side of R9. The resistive measurement we have there, 91.5 ohms for R6, R7. Next, we're going to put our jumpers back in the circuit. So we're going to put J11 to the top side of R9. We're going to take jumper 8 and put it back to the bottom side of R5. The resistant measurement we're going to try to get next is R8, R9. So we're going to take jumper 11 off the bottom side of R6. Jumper 11, the bottom side of R6. And we're going to take jumper 13, put it in the common port of the multimeter. The resistance measurement of R9, R8, 7.88 kiloohms. The last resistant measurement we're going to take is R6, R7, R8, R9. Jumper 11 is going to be reinstalled on the bottom side of R6. We already have jumper 13 in the common port. Now we need to take jumper 8 from the bottom side of R5. The resistant measurement of R6, R7, R8, R9, 7.97 kiloohms. The sixth step in the DC Theory Lab is to measure current within the circuit. The testing tool that is provided with this lab is a multimeter. This multimeter measures amperage by the inline method. Measuring total current and current throughout the circuit will require temporary removing jumpers and placing the meter in line with the circuit. The first amperage reading we will read is the amps flowing through J1. Before we measure amperage through J1, let's do a quick overview of our multimeter. So our multimeter, we have our temporary test lead installed in the milliamps port of our meter, and all of the jumpers we were going to remove from our circuit will be installed into this common port here. And the setting our multimeter needs to be in is this milliamp setting here. And let's go ahead and measure the amperage through J1. Remove J1 from the positive side of the voltage source. Install that into the common port of our meter. Go ahead, turn on our trainer. Amps flowing through J1, 0.5 milliamps. We're going to reinstall J1 back into our circuit. J1 was on the positive side of the voltage source. We remove our temporary test lead. Now we want to measure the current through J2. J2 is on the top side of R2. We're going to remove J2 from the circuit, install our temporary test lead in its location. J2 will go into the common port of the meter. We have a amperage reading of 0.5 milliamps. We're going to reinstall J2 back into our circuit. J2 was on the top side of R2. Remove that temporary test lead, reinstall J2. Now we want to measure the current through J3. J3 is on the bottom side of R2. Remove that from the circuit. Install the temporary test lead in its place. J3 into the common port of our meter. We have a amperage reading of 0.5 milliamps flowing through J3. Okay, we're going to install jumper 3 back into the circuit. Remove it from our meter. Remove the temporary lead. Put jumper 3 back into the bottom side of R2. We're going to intercept jumper 4 from the top side of R3. Install that into our meter and install our temporary lead, top side of R3. We have a reading of 0.31 milliamps. We're going to install jumper 4 back into our circuit. Jumper 4 goes back to the top side of R3. And next, we're going to measure the amperage flowing through J5. So remove J5 from the top side of R4. Install our temporary lead into that same position and install J5 into our meter. Turn our unit back on. The amps flowing through J5, 0.12 milliamps. So we're going to remove J5 from our meter and install it back into our circuit on the top side of R4. Next, we want to read the amperage through J6. J6 is on the bottom side of R3. Remove that from R3, put our temporary lead in that same position, J6, into the meter. We'll go ahead, turn our trainer back on. The amperage going through J6, 0.18 milliamps. We're going to install J6 back into our circuit. J6 was on the bottom side of R3. Next, we're going to install our meter in line with jumper J7. So we're going to remove J7 from the circuit, which is installed on the bottom side of R4. Install J7 into our meter Install our temporary jumper into the circuit on the bottom side of R4. Going to turn our trainer back on, and the amperage flowing through jumper 7 is 0.38 milliamps. We're going to install jumper 7 back into our circuit. Jumper 7 was on the bottom side of R4. We're going to remove our temporary test lead, and we're going to move on to J8. So jumper 8 is on the bottom side of resistor 5. We're going to remove J8 from the bottom side of resistor 5, install that into our meter, and we're going to install the temporary lead in its place on the bottom side of R5. The amperage going through jumper 8.5 milliamps. We're going to install jumper 8 back into our circuit. Jumper 8 was installed on the bottom side of R5. We're going to remove our temporary lead. Next, we're going to move on to J9. J9 is installed on the top side of R7. We're going to install our temporary lead in the top side of R7 and put this into our meter. So J9 into the common port, and we have 0.04 milliamps flowing through J9. We're going to install J9 back into our circuit. J9 was installed on the top of R7. We're going to remove our temporary lead, reinstall J9. Next, we want to find the flow of current through J10. J10 is installed on the bottom side of R7. Let's install our temporary lead, take J10, install it into our meter. We're in milliamps, and we're going to turn on the trainer. Again, the current flowing through J10, 0.4 milliamps. We're going to reinstall J10 back into the circuit. J10 was on the bottom side of R7. Remove that temporary test lead, reinstall J10. Now we want to measure the current flow through J11. Remove jumper 11 from the top side of R9. Install our temporary test lead into the top side of R9. Jumper 11 will go into the common port of our multimeter. The current flowing through J11, 0.5 milliamps. And now we're going to read the current going through J12. J12 is on the bottom side of R9. We're going to put our temporary lead into that bottom side of R9 and take J12, install it into the common port of our meter. Let's go ahead, turn on the trainer. The current going through J12, 0.5 milliamps. J12 will be reinstalled back in the circuit. G12 will be on the bottom side of R9. Remove our temporary lead from J12 on the bottom side of R9. We're going to remove J13 from the circuit, which is on the negative side of our voltage source. We'll install that into our meter and install our temporary lead in the spot where we took out J13. The current we're measuring flowing through J13, 0.5 milliamps. The final step in the DC Theory Lab is to measure voltage throughout the circuit. Examining Table 7, we have 16 line items to complete. The first line item is to measure the source voltage. We're going to measure the source voltage to verify it's still at the 5 volts. take our multimeter, make sure we put it in the DC settings. Take your voltage lead, positive, into your positive port, your common lead into your common port, and you can see we're right at 5 volts still. So let's make our way down the table. Let's go ahead and measure resistor 1. So measuring resistor 1. Measuring resistor 1, we have a voltage drop of about 50 millivolts. Resistor 2, we have a voltage drop of 0.513 volts or 513 millivolts. Resistor 3, we have a voltage drop of 0.411 volts or 411 millivolts. Resistor 4, we also have a voltage drop of 0.411 volts or 411 millivolts. Resistor 5, we have a voltage drop of 0.411 volts or 411 millivolts. Resistor 6, we have a voltage drop of about 46 millivolts. Resistor 7, we also have a voltage drop of 46 millivolts. Resistor 8, we have a voltage drop of 1.639 volts or 1,639 millivolts. Resistor 9, we have a voltage drop of 2.339 volts or 2,339 millivolts. Next, we're going to find the voltage drop across R1, R2. The voltage drop across R1, R2, 0.563 volts or 563 millivolts. Next, we're going to find the voltage drop across resistors 3, 4, and 5. The voltage drop across resistors 3, 4, and 5, 0.411 volts. The next voltage drop we want to find is the voltage drop across R6, R7. The voltage drop across R6, R7, 46 millivolts. Next, we want to find the voltage drop across R8, R9. The voltage drop across R8, R9, 3.97 volts or 3,970 millivolts. The next measurement we want to find is the voltage drop across resistor 1, 2, 3, 4, 5. The voltage drop across resistors 1, 2, 3, 4, 5 in our circuit, 975 millivolts or 0.975 volts. The voltage drop across R6, R7, R8, R9, 4.07 volts or 4,070 millivolts.